Hi guys, greetings from Bulgaria, I am Anton, and in this video we will discuss techniques for locating web elements using their text value, which is used mostly when the basic element identification properties such as ID or class are dynamic in nature, making it hard to locate the web element. So, first we are going to discuss the different strategies for finding web elements in Selenium and why it's hard sometimes to use ID or classes. Then we're going to see some demos, and of course, in order to understand why it's essential to be able to locate elements using text, we're going to see some more complicated real scenarios, and we're going to automate them. Of course, if you haven't subscribed to the LambdaTest video channel, please do so. Hit the ring bell so that you get notified when there are new videos. They are published each week. Also, check out the awesome blog of LambdaTest where each week are published new articles. And these two resources, I'm sure they will help you a lot in your career of test automation engineer. So, without further ado, let's begin and see the examples. First, of course, as in other videos, I'm going to use the LambdaTest Selenium Playground, which is an awesome demo website where you can play around with different demos. And for sure, this will help you a lot understanding how Selenium works, and you can use it in your tests as well. So, sometimes developer tends to group similar web elements with the same ID or the same class together. For example, if you have an element with like this input here, which has a dynamic ID, like this ID here, or this dynamic class, they can change the next time when you load the web page. This means that you cannot rely on this particular locator like ID or class. And in this scenario, it gets harder to locate the elements. And I will show you how you can still do that with CSS or XPath. But there are other cases where even this is not an option. And we will discuss some of these scenarios. So first, let's see some simple examples. You can find the full GitHub repo in the links below. You can download all the examples for free and play with them. Just let me quickly explain the project structure. This is a standard JUnit setup for Selenium, and we use Maven for project dependencies. If you are not familiar with JUnit or TestMu, check the LambdaTest channel. There are really awesome video series about this. Also, there is a whole series about all different interactions with Selenium. So I will just shortly explain all of the dependencies here. We have all of the JUnit dependencies from Maven repository copied. We'll use WebDriver Manager to download the proper browser driver version. And of course, we have the Selenium 4. Then our test class, we have dependencies to WebDriver. Before each test, we start the browser, and then after each test, we close it. Before all of the tests, using the before all annotation, we basically call WebDriver Manager, who is responsible for downloading the proper driver version. We maximize the browser, and also we initialize WebDriver wait. If you're not familiar with what is WebDriver wait and what for we use it, check out my video on the LambdaTest channel about waiting for elements using WebDriver wait. It's a really detailed video explaining all the different possibilities of this amazing class. So we have two options how we can find elements in Selenium. As you know, we using the driver when you call the method FindElement, we're searching in the whole browser, and we provide using the by class. It has a few methods for providing locator strategy. For example, here I used XPath, but available for you, you can locate elements using class name, link text, ID, CSS, name, partial link text, and tag name. So yeah, you have these options. Also, we have additional method called FindElements, which is excellent for finding more than one element. It will return a list of web elements. And as we'll discuss in the second example, we can search not only in the whole browser, but for example, when you locate a table row or a table, as you will see in a minute, we can search only in this particular web element instead of looking into the whole page. So let's return just for short to the LambdaTest playground. Imagine that we want to select this particular checkbox. To do so, you need to open Developer Tools with F12 or directly open the context menu and click the Inspect Context Menu item. And then, as you can see, this is the link. You can, of course, for links, you can use by.link text or partial link text. However, sometimes this is not possible. Imagine that we can find this particular link using XPath. And the way we do that is by starting with A, this is the A tag, and then in the brackets, as you know, when we put A, we get like tags, but here I will use just text, and I can name it to checkbox demo, right? Or you can use single quotes, and we find it by basically this text here should be completely equal to the text here. However, sometimes imagine that we want just to find the link just by one of the words, for example, demo. It's easy to do so. There is another XPath method called contains. So we first call contains. Don't forget the brackets here, parentheses, and then you provide comma because it accepts two arguments. First, the text where we search for, and then just a single word. Also, you have additionally other verbs. Instead of contains, you have ends with or starts with, and they can help us also to find some of these elements. Or you can use starts with. Anyway, I usually prefer to use contains. And also you have another method called normalize text, and this normalize space function. This function should wrap here the text itself, like here, like this. And this normalized text, the thing that it's doing is that it strips the leading and the trailing white spaces from a string. It replaces sequences of white space characters by a single space and returns a resulting string. Imagine that in some HTML markups, your HTML may look like this. And then in this case, you still want to be able to find your locator, even if you don't use contains, but just equal. So in these cases, you can use normalize /space. And in some cases like here, we can find even more than one row, right? For example, like here. As you can see here, we have 5 elements. When you press enter, we'll find each of them. So this technique for locating elements is excellent. And let's see it in action. Let's see some examples. I automated these scenarios in the solution that you can download. First, we navigate to the LambdaTest Selenium playground. Then we use FindElement, and by XPath, as you can see here, we check that the text is equal to checkbox demo. Then we click it and we get the heading, and we check that the right heading, the right page was loaded, right? And the second thing with the table links, instead of using FindElement, this time I use FindElements method, which will return, as we discussed, list of web elements, and then we can for each them all of these table options, and we can print their text or verify something. It's up to you. So as I promised, I think it's hard from simple examples like this to understand why it's so important to be able to locate elements using find by text. This is why I prepared two more complicated demos. For one of them, we're going to use this demo website presenting an j query controls by Telerik. In the past, I had to automate them, but there are many such examples, not only these complex controls, but in other cases in enterprise projects, you have these complex tables where we don't have IDs, or you don't have a stable class, and the only way to interact with the elements is just to find it by unique text. Usually the way we automate that is that we use the microservices and the web API or the database engine to insert unique test data, and then when we know the expected data, we can use it to locate particular rows. Imagine that, for example, this name is unique because we inserted it, or this one, and we want in our tests, when this page has been loaded, to check the checkbox by name. Again, it's up to you to insert the right data so that we are sure that the names are unique. So let's inspect it and open DevTools. As you can see here, this is a regular data table, this grid, and first we want to select this table data row. Let's do that. It's easy. Like, we can use the same technique that I showed you. We can just use equal. So we have td, then square brackets, text, equal, single quotes, Ryan, Simon, and this is the table row. However, as I said, we want to be able to select the whole row first, and then inside of it we can search for the grid cell that it's a checkbox. And this is the first example that I'm going to show you. First, let's think how we can select the upper table row. In order to do so, we many often, when you locate an element using text, like the way I showed you, we use a technique called XPath access. This is a special XPath locator, which allows you to go up or go down, and we can traverse the tree. So using that, XPath access give you methods like following, sibling, parent, and in our case we can select the parent, which is this table row tr, and we can say like this, parent, and in order to switch the access, meaning get the parent, we need two columns, and then put the searched tag, which in our case is tr, which is a table row, like this. After we have it, then after we located this web element, we can just search inside of it to get the first grid cell that inside has an input. When we search for such, if we use XPath and we type //td/input, in order not to search in the whole page, in the whole browser, but just inside this element, we need to put dot in front of the XPath. This instructs WebDriver to search just in this particular web element, because this is possible when you use XPath. So let's see it in action. What is this two lines here using cookies? If you haven't watched my video on the LambdaTest channel about cookies, please do so. There I explain how to use them, and I show there how you can automate some complex scenarios of these consent screens. Let me show you. This consent screens, as you know, this is related to GDPR in Europe, and we need to agree that we consent to the website to collect our personal information like cookies. So if I open DevTools, just really quick, when you go to application and here cookies, you can see the two cookies that are applied right now. When we click accept here, as you can see, there was really quick, because I'm in incognito, they were deleted, but here if I open it, I already consent. So in this particular case, we have a cookie called alert box closed, and when you add it and refresh the page, this consent screen will go away. And you can do that instead of every time search for these accept buttons, switch to alerts, and then click it. So this is what I did here. I just added the cookie by this name. I showed you what it is. Sometimes you need to generate some values, but again, from case to case, it will be different. Sometimes will be the current date or something else, but for sure you need to refresh. And then let's see what else. First, if we refresh here the page, you will notice that we have this loading screen. Depending on your network speed, this can take some time, right? So we need something to wait for, and we'll use WebDriver wait. Again, if you are not sure how to use it, I suggest you to check my video about WebDriver wait and waiting for elements. But the thing that I did here is, let me show you. I use WebDriver wait that we initialized here in the before each and I use this special class expected conditions that has a method called presence of all elements located by. And basically I wait for all of the checkboxes here, or we can wait for particular name. Let me show you here. So here we wait for Christian Palmer parent table row to appear. This is the name that we search for. You can extract this to a separate method where as a parameter you can provide the name, and this way using string format, and this way we can generalize a bit the logic. Then, as I promised, we need to find in the table row the first input. Let me quickly remind you. Until now we found some of these rows here, this row, the whole row. However, we want this input. So in order to find the input, we can search inside this particular element. So we can assign it to a variable here called table row, and inside this table row we can search for the checkbox. So here, as you can see, we are not directly searching in the driver itself. You can do this as well, but this will be wrong because you will get basically this dot notation won't work. But when you search inside other element, don't forget to put the dot. This means that you're going to search inside the element. And this way we will find the checkbox itself. Then we can click the checkbox and select it. And if we want to assert that the checkbox was checked correctly, we can use the checkbox is selected, which returns true or false whether it was selected or not. Let's write one more example. imagine that right now we check just, we selected just a single element by equals to the particular name. But imagine that we want to do it not with two locators but with one, and we want to find all, to check all of the rows that has a QA position. How we can do that? If we inspect it here, we have again this table data cell. Let me inspect it here. Inside we have here the position, so we can write td where this time contains, don't forget the brackets, then inside we have the text which is equal to QA. And as you can see, we have 5 such rows, right? So we selected the QA engineer and all of the QA positions. Similar to what we did before, we need to get the parent table row. Here is the table row. And now, instead of using two locators directly to search with FindElement here the input, we can write this in a single locator. We can continue now as a regular XPath to write td/input. In our case, this will select the checkbox. It's easy as that, but again, we found that by this unique text that again we can put this inside some general methods using string format. So here is the same test with finding all QAs. I'm doing the same thing with the cookie. Here we found all of the checkboxes with a single locator and we are waiting directly for them. This WebDriver wait until function, which is presence of all elements located, it's actually returning the list of these web elements, so you don't need to find them again. We are going just to wait for them. Also, as we did in our second example, it's easy just to for each them and click them. So we have here the current checkbox, so I can just click all of them like this. However, these are 3 lines of code. You can do the same using Stream API. So we can write it, this is equal, this is the same code. So we can just for each them like this and clicking them, or we can call stream for each, and then using lambda expression we can click all the checkboxes. And of course, as in the previous example, we want to verify that we checked all of the checkboxes are checked, so we can use the same lambda expression, but just inside we're going to call assertions, assert or equal, whether it's selected or not. And let's see one more example. This is even more complicated. This is jQuery grid, and inside of it, as you can see, inside this grid we have Trivium with categories that we can expand. Then we have here images with more complex items, etc. We have cells, and imagine that in this particular code, the thing that we want is that with a single locator, I want to close all of the categories that are, for example, below this amount, and we want just to check. After that, we want to check all of the checkboxes for the names here that start with T, but just for the categories that are above this amount. Let's do that. How we can do it? Well, of course, we need to inspect it, and in order to select that, we can first use locator like this. As you can see here, we using contains and text, we can wait for all of these paragraphs to appear, and this means that the page has been loaded. After that, we need to parse this amount, so we need to find all the categories, get their text. We need to split this string here, for example, by this symbol here, this means that the second part will be the amount that I need to parse, and then we need to filter them and compare that this number is below this amount. And there is a second problem here. When we parse these amounts, it depends on what is your computer locale. In my case, I'm in Bulgaria, so in Bulgaria this formatting is not correct. We don't have these commas here. This is US formatting, so in order this to be correct, I need to change the locale for the parsing option to be set to US in order this to work. So let's first do that. Again, we have the same consent logic here to close the consent screen. Then, as I explained before, we wait for all of these paragraphs to appear. This is how we make sure that the grid was loaded correctly. In order your parsing to work, as I said, we use this number format, get number instance, and we provide locale US. Otherwise, again, if you're not in US, probably the parsing will fail. And let me explain how the next complex logic is working. So I get all of my categories and their text, right? Then I call stream API. Inside the stream, I can filter them. Again, this is a similar thing. You can do it with just a regular for each, and then we can have a list. That's perfectly fine. So instead of doing that, maybe we can do for each category inside categories. Or something like that, and then you can have you can have if statement, this is the filter, and then we can collect them in another list. So the thing that I do here is that I filter all of the elements inside, and the thing that I do is that I get the number format, get instance US, I parse the text basically by splitting by this $, and I get the second part because we start to count from 0, and this is the parsed value. Basically this is just the number, and I check that the value is bigger than greater than this amount, and this is our condition. Basically this is our condition to filter. Basically we will get all of the categories that have amount above this. This is just the parsing. This is regular parsing in Java, but with this particular locale, as I said, it depends on the formatting. So this is the first part here with the filtering, and then in the stream API we have this map function. This map function basically allows us, since we are filtering web elements, but we want to select only the text value of the categories. Basically this instructs the stream API just to put in a list just the text of this category paragraphs. So basically here we will have just the text of the amounts that are above this particular amount. You can play with it, you can try to rewrite it the way that I showed you with for each statement, and put them in a separate list. But again, the code will be probably double this amount. So here we are just for reaching this text of these categories, and I'm building dynamically the locator for the link below for the expand button, because we want to expand them. What I mean here is that first you have here the category, but as you can see, this text here is actually So basically we selected the paragraph, but we need to select the anchor and click on it. This is the expand button, so that we can collapse them, right? This is why I'm getting only the categories with amount above 27,000, and we are going to collapse them. So this is how we formatted them. As I said, this is a very popular technique. In many enterprise projects we do the same. We just format, we have these format functions to build these dynamic locators. So this is how we find the expand link, and we can click them. After that, the second part of our task is to find these checkboxes here by the divs that are visible, and start with T. How we can do that? If I inspect here the element, you can see that I have a class with product name, because this is a div. I cannot search just divs with T because we're going to select many other stuff here. So we can find a div where we have contains with text, where we have T, but as you can see we selected others, but we want to select only this type of divs that contains product name. So we can use contains text, but we can also set with end that we want a class that is equal to product name, right? And this is how we found, for example, with T, or you can use starts with, that's fine. Here it is, tofu, product name. And now we want to select the table row, actually the TD, and then we want to select the table row. So we first need to select the TD, which means that instead of parent, actually we have the photo. So yeah, we need first parent TD, which is this one. And then this is this checkbox. As you can see, we have 4 options. Here it is. So we have the checkbox here, so we can get the preceding sibling, because we can do parent again and then search for the second TD, but this time it will be easier just to select the TD that's above it. In order to do that, because they are on the same level, we can use preceding slash sibling slash TD, which is the checkbox, and also we can get maybe by class here specify that we can specify that we're searching for the checkbox. As you can see, we have a special class for it, which is checkbox align. As you can see, it's a little bit more complex, but in reality we have to write such complex locators. Let me show you how to do that in the test here. So we go driver, find elements, we have div, class, product name, starts with text T, parent, preceding sibling, TD that has a class that it's checkbox aligned, and then we select the input. A bit long, but that's it. Then using Stream API or just a simple for each, you can check that the actual checkbox is displayed, because it can be hidden because we collapsed many of the elements. So we need to write this check here, whether this checkbox is displayed, and then we click it. and it's relatively easy, just again using Stream API. Again, we check whether the checkbox is displayed, and then we assert that that it's selected, right? So that was the thing that I wanted to show you. Thank you for watching. If you have any questions, put them in the comments below. Also, check out the awesome blog of LambdaTest. As I said, there are many awesome articles that are published each week. Check the community.lambdatest.com. Don't forget to get your free LambdaTest certification about JUnit, Selenium, and many more. They can help you to in your career. And see you in the next video. Thank you.